So now I'm going to go to the next one, which our next one, since we just finished both of these, we are on signature versus behavioral detection. So help with my course, and then I go to signature versus behavioral detection, right? Detection methodologies in cybersecurity can be broadly categorized into two primary approaches: signature-based detection and behavioral-based detection. Understanding the key strengths, weaknesses, and appropriate use cases for each method is crucial for building effective security monitoring and response capabilities. Signature-based detection identifies threats by matching known patterns, fingerprints, or signatures against observed data. It relies on predefined rules or patterns that uniquely identify malicious activity. Pattern matching, database-driven, deterministic, and rule-based matching. For types of signatures, we have file hash signatures, string-based signatures, which is like a string of data, right? Byte pattern signatures, which is like a specific number of bytes, stuff like that. For dynamic signatures, we have network signatures, snort rules. So this could be like a rule in the firewall, right? That could be a rule on the firewall. Any on any 80. So that's like port 80, I think. Port 80 is HTTP, right? HTTP get HTTP method, right? Yara rules is pattern matching for malware identification. Suri Kata rules, network intrusion detection attempts. So those are some of the rules that you'll come into, right? You'll come across. For protocol signatures, we have specific network protocol abuse patterns, malformed packets, structures, unusual protocol usage patterns, command and control communication patterns. We also have implementation methods, antivirus, anti-malware engines, traditional AV approach. Signature database contains millions of malware signatures, real-time scanning files checked against signature databases, heuristic analysis, late behavioral analysis for unknown threats, cloud lookup, real-time reputation checking, file access, hash calculation, database lookup, match found, alert blocked for the flow of the detection. For snort example, right, we have that malware, that malware CNC, Win.Trojan agent. So right there's the message showing that it's a Trojan agent, right? Flow into the server. Content is this right here. Depth is for content. For email security, we have attachment hash checking, URL reputation analysis, sender reputation score, content pattern matching. For email security, I think DMARC. DMARC is really, really important, right? Advantages of signature-based detection: high accuracy for known threats, low false positive rates, exact matches provide high confidence. We're not going to go over all this, right? But I want to go over limitations, right? 0-day vulnerability. They have no idea about this threat. So how are they going to be able to detect it? They're not going to be able to detect it, right? For signature lag time, we have gap between threat discovery and signature creation. Polymorphic malware. Self-modifying code evades static signatures. Encrypted payloads cannot inspect encrypted malicious content. Pack encrypting, malware obfuscation to avoid signature detection. They're packing it. So basically what they mean by packing, you know, like a zip file? You know what a zip file is, right? So basically what they do is they pack it into zip file after zip file after zip file with different zip file types, so that an intrusion prevention system would allow that file to go by. It'd be like, I don't care, that file's allowed to go by because it's just a regular old zip file, isn't it? But there's malware deeply embedded in that, so that the intrusion prevention system won't be able to detect that, right? At least being able to get into the system, right? And then whenever it gets on the system, they have a script that automatically unzips all those files and then runs the malware, right? That's like some crazy stuff, isn't it? But that is how some payloads can get in. They zip file, and it's just like different. They have like GZ, they have like tar files with GZ, and they have just different zip file types. And they just pack it down. And then they have like a script that they would later get on the system and run to unpack that malware, right? What's living, this is some of the stuff you guys need to know. Packaging, encrypting, malware obfuscation to avoid signature detection. Code mutation, changing non-essential code to alter signatures. Living off the land. What is living off the land? Using legitimate tools for malicious purposes. I mean, you see Excel, right? They used macros in Excel, right? To put malware on a system, right? To run an application, to run some type of malware. That would be something like a living online attack, right? If Excel just, whenever you open up a document, it ran a macro that then opened up a malicious file. For fileless attacks, that's stuff that happens in memory, right? Memory-based attacks without file signature. For behavioral, what does behavioral mean? How a program behaves, or how a person on a network behaves, right? This is how they detect it. They're not relying on those signatures. They have to be really, really well tuned. They are relying on network-based anomalies, activity patterns. What is the person doing on the system? They are figuring out what they're doing on the system with UBA, user behavior analytics, right? User behavior analytics, right? For activity monitoring and baseline establishment and anomaly identification and context analysis, that's like the core of having good behavioral detection, right? For behavior analysis, we have host-based behavioral analysis, process behavior monitoring, process creation and termination patterns, parent-child processes relationships, resource consumption anomalies, registry and file system modifications. So in Windows, you have registry, right? Registry editor. We have memory analysis, memory injection techniques, process hollowing, detection, DLL, hijacking identification, heap spray detection, system call monitoring. We have unusual API call sequences, privilege escalation attempts, system resource access patterns, inter-process communication anomalies, network behavioral analysis, right? Traffic pattern analysis, bandwidth utilization, right? They're analyzing that traffic, connection patterns of normal network connections, unusual protocol usage, periodic or beaconing behavior, right? Communication, like a C2 command and control server, data exfiltration, large outbound data transfers, lateral movement, unusual internal network traversal, domain generation algorithms, algorithmic domain request, UBA, user behavior analytics. That's what I was talking about earlier. Login geographic access variations, authentication failures, privilege usage changes. So they basically get all this, right? What's it called? All this fingerprinting, right? From this user. And then they go a step beyond that and they try and figure out what that user's doing. File access volume changes, sensitivity, data access patterns, database query anomalies, and email behavior changes. So they go get that fingerprinting, which, what is fingerprinting? Like, every time you go on a website, that website's getting, like, fingerprinting data from you, right? It might be getting what your IP address is, stuff like that. And there's a lot of other stuff it can get. For EDR, they have real-time monitoring, continuous endpoint activity observation, historical analysis, threat hunting, automated response. So this is like an example of EDR detection. PowerShell.exe. Parent is Winward. The command line runs the PowerShell with a base 64 encoded command, which downloads a file from an external domain. And this is a high risk score because they're downloading some malicious file off the internet. Boom. Document spawning encoding PowerShell, right? User and entity behavior analytics. Machine learning algorithms, statistical modeling, risk scoring, and context correlation. So that's the difference from UBA and UEBA. So this will be an example UBA alert. So that's the user. He's accessing 500% more files than the baseline that you're supposed to be able to do. Outside of normal business hours. Geographic anomaly detected. That means that he's in like a different place that isn't at the work and stuff like that. 85 out of 100 potential insider threat. So they just detected it, an insider threat just like that. Boom. Well, they actually have to go confront him and everything to make sure he's the one who did it, right? Network detection and response. Deep packet inspection, application layer analysis, metadata analysis, connection and flow pattern analysis, machine learning classification, automated threat categorization, behavior baselining, network normal state establishment. For machine learning, we have machine learning and behavioral detection, supervised learning, training process, label dataset featured extraction, model training, validation testing, production deployment. So that's some of the like machine learning models, right? Neural network, we have recurrent neural networks, LSTM, long short-term memory. So you're given that machine learning program memory so that it can memorize this stuff, right? Convolution neural network and autoencoders. For behavioral detection, we have zero-day protection, evasion resistance, living off the land detection, advanced persistent threat detection, right? For adaptive capabilities, we have self-learning systems, continuous improvement through machine learning, environmental adaptation, adjust to specific organizational patterns, emerging threat detection, identifies new attacks techniques, context-aware analysis considers situational factors, comprehensive coverage, broad threat spectrum, detects various attack types and stages, insider threat detection identifies malicious internal activities, lateral movement detection, tracks adversary progression, data loss prevention identifies unauthorized data access. So, for limitations of behavioral detection, we have false positive challenges, legitimate anomalies, normal but unusual activities flagged, baseline drift, changing normal behavior affects detection accuracy, seasonal variations, business cycle changes to impact baselines. I'm just going to zoom that in a little bit. And user behavior diversity, right? Because users are going to be doing so much different stuff. You're probably going to be getting some false positives, right? On that UEBA stuff. For comparative analysis, we have initial detection, right? Minutes to hours, stuff like that. This is just little charts that you can look at. And then we have hybrid detection approaches, right? Layer 1 signature-based filtering. Known threat elimination. Removes obvious malicious content. Performance optimization. Reduce load on behavioral systems. Immediate response. Block confirmed threats instantly. False positive reduction. High confidence detections first. But for immediate response, what happens is like, if you're downloading a file that's malicious, it'll automatically be like, nope, you're not downloading that. And then cancel out that download because it thinks it's malicious, right? False positive reduction. High confidence detections first. Behavioral analysis rate. Unknown threat detection and analyze suspicious behaviors, context enrichment. Add environmental information, risk scoring. Quantify threat likelihood. Advanced correlation. Related activities. Layer 3 is human analysis, right? Expert investigation. Skilled analyst review of alerts. Threat hunting. Proactive searching for advanced threats. Incident response. Coordinated response to confirmed threats. And continuous improvement. Feedback loop for system tuning. For machine learning enhancement of signatures, we have automated signature generation, right? Behavioral pattern extraction. Convert behaviors into signatures. Dynamic rule creation. Generate rules from behavior analysis. Signature optimization. Improve existing signatures using machine learning. False positive reduction. We have machine learning driven signature refinement. Intelligent signature selection. Context-aware signatures. Adaptive signature weighting. Predictive signature deployment. Performance optimization, right? So the best practices is here, but I'm going to go down to use cases. So for use cases, we have a scenario of a mass malware campaign, widespread distribution of known banking Trojan, detection method, file hash signatures, response time, immediate blocking, outcome, 99.9% of infections prevented, signature detections, XLs at known threat prevention. Known, so it's not going to be detecting those zero-day vulnerabilities, right? Network intrusion attempt is the number 2 scenario. Known exploit attempt against web application. Detection method, network signature matching. Response time, real-time blocking. Outcome, attack prevented at network perimeter. Lesson, network signatures provide effective perimeter defense. Behavioral detection success, which we don't have to go over all of that, right? Future trends I want to go over. Artificial intelligence integration, AI. Advanced machine learning algorithms. Improved behavioral pattern recognition. Natural language processing, enhanced threat intelligence analysis. Computer vision, visual pattern recognition, and security data. Computer vision's like, they have that little camera that can detect what stuff is, right? Reinforcement learning, self-improving detection systems. Cloud-native detection, serverless detection, scalable, event-driven threat detection. Container behavioral analysis, specialized detection for containerized environments. Multi-cloud visibility, consistent detection across cloud platforms. Edge computing, integration, distributed detection capabilities. Quantum computing, quantum ready security. Quantum computing is basically like these really, really, really smart computers, right? That later, when they get more developed, will be able to crack encryption, right? So right now they can't crack SHA-256, right? They can't really crack 256 encryption, right? But we have post-quantum cryptography, updated signature. But this isn't talking about cracking encryption and stuff. This is talking about cracking signature files, right? And having better signature files. Updated signatures for quantum-resistant algorithms. Quantum behavioral analysis. We have new behavioral patterns in quantum computing. Hybrid quantum classical combined with traditional and quantum detection methods. So that combines like the cryptography and the behavior analysis, right? So this is talking about the quantum resistant algorithms. That's what I'm talking about when I'm talking about cracking, right? Because we want updated signatures that can't be cracked by quantum algorithms, right? For AI, we have signature evolution, right? AI generated signatures, machine learning creates new signatures, dynamic signature adaptation, real-time signature modification, collaborative signature sharing, industry-wide threat intelligence sharing, behavioral signature fusion, converting behavioral into signature patterns, behavioral enhancement, federated learning, privacy preserving, collaborative machine learning, explainable AI, transparent behavioral detection decisions, automated model retraining, continuous learning without human intervention, cross-platform behavioral correlation, unified behavioral analysis across platforms. Conclusion: both signature-based and behavioral detection methods play a crucial role in modern cybersecurity. Signature-based detection provides fast, accurate identification of known threats with minimal false positives, while behavioral detection offers advanced protection against unknown and sophisticated threats. Key recommendations: implement both approaches. Use layered defense for comprehensive protection. Start with signature-built foundation with proven signature-based systems. Add behavioral capabilities gradually. Implement behavioral detection in phases. Invest in analyst training. Develop skills for behavioral alert investigation. Measure and optimize continuously. Regular assessment and improvement of both methods. Plan for integration. Ensure both systems work together effectively. Consider organizational maturity. Match detection sophistication to organizational capabilities. So that is that for threat detection with signature versus behavioral, right?